So my name is Lakshmi. I basically work with a bunch of folks building this Blueflood, which is a multi-tenanted time series data store. So the front-end part of it is called intelligence.rackspace.com. So if you go there, all the graphs that you see on that website is basically powered by Blueflood. First up, the credits. So this Blueflood is a project built by a lot of engineers at Rackspace. Here are some of the names. If you have any questions or comments about the product itself, there is Mark sitting here. I don't see James. So if you have any questions, please feel free to talk to him after the talk, or you could grab one of our engineers too. So what is Blueflood? So this is the hallway joke. Whenever I walk around, people tell me that, oh, you're building a distributed calculator that loves numbers. Fantastic. So what really is Blueflood? It's a time series data store built on top of Cassandra. You basically get HTTP access to ingest and query your data. So we support numeric metrics as well as string and Boolean metrics. And also Blueflood is open source if you want to hack on stuff. So why did we build this? So we have this product called Cloud Monitoring, which basically is responsible for collecting interesting metrics about your servers and also your websites. It runs in 5 different data centers, collects a lot of good information, and it also alerts whenever things go wrong, right? And what we decided was that if there is a metrics backend which basically stored all this data and we could do summarizations, it would be really cool. And also if you expose APIs so front-end people can actually write dashboards on top of this data, that'll be super cool. That's one of the reasons we built Blueflood. Rackspace has a lot of customers, so we needed this to be multi-tenanted from day one. And also we needed a data store that scales horizontally as number of customers grow and number of individual metrics grow. So how is Blueflood built? So there is a shortcut icon, and if you click open it, and it doesn't work. Oh, it did work. No, it didn't. I'm sorry, I'm bad at all this presentation stuff. It basically takes you to the code. See, so you'll have to, there is no shortcut really. You have to read the code. But I'll cover some aspects of how. So you built all this, what did you get? So now Rackspace Cloud Control Panel actually shows cool graphs for all your stuff. And we are also able to ingest billions of data points per day from our customers, which is really, really good. So the first question, whenever people see me, they ask me, why did you pick Cassandra? Why not HBase versus some other databases? Basically, Cassandra gives good write throughput, which is what we are after. For example, a stock Cassandra configuration and performance cloud server on Rackspace, we ran an experiment and we could ingest 60,000 points per second on a single box. You'll have to tune some parameters there. I'm not going to go into the details, but at some point we'll write a blog post about it. We also get like reasonable read performance. It depends on your queries, your time ranges, and whatnot. But the read performance has been like really acceptable for us. Cassandra a data model allows you to store time series data really well. The column-oriented database actually works good for us. And Cassandra also supports native TTL, which is good because we want our metrics to go away from the data store at some point. The cost of storing fine resolution samples is just exorbitantly high in terms of cost, right? And we also have a Cassandra committer in the team. Gary is sitting here, so that is also one of the reasons we picked Cassandra. We also have like good DevOps experience running Cassandra because of CloudCake, which was a company that did monitoring, then acquired by Rackspace, turned into Cloud Monitoring. So the other question, the golden question. So how do you compare against OpenTV, Kairos, Cyanide, Graphite, Influx, a bunch of stuff? So I'm going to like briefly touch upon each of these tools, which are very, very nice tools, by the way. So InfluxDB, it uses LevelDB under the hood. So they try to do like all the fancy replication at their layer instead of database actually handling the replication. So it's when you want to run your thing in high availability mode across data centers, LevelDB is not really suitable for that. But I personally haven't looked at the LevelDB source, so it's just what I read from the internet. Also Graphite, we use Graphite too. We love the tool. It provides like good ways to query your data and also like good aggregation functions and stuff like that. But then when you have a lot of metrics going into it, it's not really scalable. Then you end up with a federated Graphite and your queries become really slow. So there is a new project called Cyanide, which is also using Cassandra under the hood, but they went with a single giant column family model where you put all your metrics and also summarizations in the same column family. It's a neat project, but I don't think they have thought through the operational aspects of using a single column family well. So KairosDB is also interesting, but I looked into the source. KairosDB does few things really well, but they also went with a giant column family, and also they have a column family for tags. The data model, I don't think they did it well. That's my opinion. OpenTSDB is one of the real competitors. They use HBase, but I think like we wanted Cassandra as our data store, which we understand more than HBase. That's one of the reasons we picked Cassandra and decided to build this from scratch. So like any metrics gathering system, Blueflood has like 3 primary components. One is the ingestion module, the rollup module, and query module. Ingestion module is basically responsible for handling metrics. So you could actually use HTTP APIs, post JSON into it. The ingest module basically handles it. The rollup module is the one that actually does the computation and summarization. The query module is what the users actually hit with their read requests. So like I said, the ingest module, you would pretty much use a HTTP post with a JSON body. I'll show you some examples in forthcoming slides. But production today uses Scribe, which is what cloud monitoring uses for all its data. The alerting system also sits on top of Scribe. So we wanted to just piggyback on the stream. So we use Scribe today with Thrift. And you could also write like custom ingestion adapters if you want. Like if you don't want HTTP or Scribe, you can write your own adapters. So how does a metric actually look? The metric has a name like that, and a value, which is usually numeric. We support like arbitrary precision there. And you can supply a TTL for the raw sample, and you can also supply a unit. So if you click open this link, this is going to give you like a curl command. And I'm terrible again. Okay. So that's how you would do like a post request to an instance of Blueflood running on your box. Yeah, it's a very simple JSON structure. So in terms of the rollup module, we decided that we want to support fixed granularities. We did not want to support arbitrary granularities because we wanted more control of the system. So these are the granularities we support today. The day rollups are basically UTC time aligned. We don't do like any other time zones right now, but we are actually thinking about it. We also do restricted set of rollups. So we do what are called basic rollups, which is just computing mean, min, max, standard deviation for your numbers. That is what we call basic rollup. Apart from that, we also support stats-t type of metrics like counters, timers, gauges, and sets. The support is experimental. We're just making a lot of changes. So if you're trying to use this in production, you should expect bugs. Same thing with histograms. We just recently added it. It basically computes like your distribution of data for every granularity. And we don't do any rollups for strings and Boolean data. So the query module, basically you hitch the HTTP API either with the get, if you want to get like time series for a single metric, or you hit with a post with a list of metrics. We support like both batched reads and single reads. And today you can identify a time series just by a metric name. You cannot, you don't have like secondary indexes for referring your metrics. And we support just 2 types of calls. One is get by points, and the other one is get by resolution. The get by points is primarily useful for people who want to just plot graphs based on data that's in Blueflood. So we are targeting customers who want to do visualization. Get by resolution actually is used by people who want to do more analytics kind of stuff. They might also end up using get by points. We're like still debating if these are just 2 good choices, or do we need to consider more. So we don't support any fancy queries yet. Like you cannot do like glob expressions and stuff like that, which is something that we are thinking about. Like input adapters, you can also write custom output adapters, transform like the data from Blueflood into whatever serialization format you want, like message pack. Let me show you an example of how retrieve metrics would work, the curl command. I don't know if you guys can see it, but there is actually like a from timestamp and a to timestamp. That's how you specify the range, and these are like milliseconds since epoch. And you can also say like how many points you want for this time range, and you basically get a response like this. So there are, apart from the primary components, there are like optional components. We have an Elasticsearch indexer module, which basically would help you do searches for your metrics. And we also have like a cloud files exporter. So if you want all your rollups to end up in some place, then cloud files are, we also support Apache Kafka exporter. So you can set up a Kafka cluster and things would go into that. So these are like primarily useful for people who want to run more analytics on top of the rolled up data. So if you want like other granularities, then you probably can export to Kafka and write like a thing that would compute those summarizations for you. So I'm going to just give you like a 10,000 feet overview of Blueflood architecture. It's a very, very simple model. So you basically have metrics. Metrics are partitioned into shards. We use like 128 shards. And each node is responsible for a set of shards. So once a node is assigned a set of shards, it goes, fetches all the metrics that belong in the shard, compute the rollups, write to the time series data store. And also for redundancy purposes, each Blueflood worker also has a peer who's also responsible for the same set of shards. These are coordinated by Zookeeper, so you don't end up doing the same work twice. It doesn't hurt, but you do want to try and avoid duplicate work and writing to databases. Also, like when metrics come in, we map each metric to a slot, and it is a rolling window of 14 days. So slots are basically the unit of work Blueflood sees. So, we also have a scheduler that figures out when a slot is ready to be rolled. But I'm going to skip on that part. It's complicated. OK. So a little bit about our Cassandra cluster. So this is going to get into the operations aspects of Blueflood. We have like 32 nodes running across 2 different data centers. We use replication factor of 3. And everything is written and read at consistency level 1. Because, I mean, we can change the consistency level at write penalty cost, but we want to optimize for performance at this point. And all our code base is extensively written in Java, so we use like a client library called ASDNX, which under the hood uses Thrift to talk to Cassandra. So in terms of Blueflood deployment itself, like Blueflood a process can run in any of the 3 modes I talked about: ingest, query, or rollup, and any permutations of these. So we actually run 2 nodes just in ingest only mode, because ingestion can be like memory intensive. Also, we situated like Blueflood processes on the same boxes as DCAS. It's not really required. At some point, we were trying to optimize the latency to CAS, so we did that, and it has actually worked well for us. And at some point, we will be open sourcing the Blueflood chef recipes as well, so you'll not have to spend time setting it up. So more about operations. So Blueflood is heavily instrumented. We use CodeHell metrics library in Java, which basically summarizes all the metrics collected from Blueflood. We today use Graphite to observe our stuff, but at some point we would be deprecating that and switching to Blueflood itself. Some work has been done. I'll talk about it a little later. We also use like Rackspace monitoring agent plugins to capture KPIs from Blueflood and write into Blueflood. So that's one way of like dogfooding this system. And we also have like command line tools that will help you to dump metrics, roll data whenever there is a production issue and you want to like quickly look at data in the database, bypass the entire system. So we have thought about it and built some tooling around it. Okay, this is a cool story. So like, tell me some more numbers, right? So we ingest around 1 million individual data points per minute. At some point, we were peaked at 3 million data points per minute. We also roll more than 1 million individual metrics today. And we hit a peak of 3 million Cassandra operations. But if you look at the read queries, they're more like 500 a minute. There is a reason. People like want to look at graphs only when their stuff is broken, so the read requests are not like that common compared to writing, which actually fits the reason why we wanted to use Cassandra in the first place, because we are optimizing more for write throughput versus read throughput. So in terms of the team itself, we have like a fairly small team. Gary is a remote developer, and most of the communication actually happens on IRC asynchronous. We are not big on process, but everybody owns it. So when things go wrong, everybody's actually looking at stuff, trying to figure out why things broke. And also, we have a rule that every merge to master must be deployed. And whenever you write code, instrumentation is like vital. So if you're not adding metrics, then we're going to be harsh on the PRs. Like we basically made most of the product and project decisions things. So some of the features you can expect from Blueflood in the future, one would be Graphite integration. There is some work already done there. So you can use the Graphite dashboard, but all the metrics would be served from Blueflood itself. And there would be like a Carbon backend, so you can also ingest metrics. Yeah, something we also want to support is tax-based metrics retrieval, like you said, like for logs, but we want to do it for metrics. And we want to also support like richer queries and aggregation functions like Graphite. That's part of the reason why we went and built the Elasticsearch component. So in terms of technical lessons learned, most of the operational issues we have seen, major ones, have been due to Cassandra itself or our lack of understanding of some details of Cassandra. So when we built this, we built so that we have different column families for different granularities. So if you want to try out some, I don't know, for example, level compaction versus size compaction, you could selectively do it on a single column family, and you will just impact that column family. Usually we pick day rollups because that's the one that will not have immediate customer impact. So we can try out these things. So that's a good reason for splitting metrics into different column families. For example, histograms go into their own column families. Stat-C metrics go into their own column families. So if you mess up something with the code, we can just drop the column family and not worry about it. And things we have also learned that a live upgrade of Cassandra Cluster is not really easy. We tried to upgrade from 1.0, which is what we use in production, to 1.1, and it did not go well. Also, the Cassandra RPC type, we tried using HSHA, which is apparently more performant than sync, but it turned out to be otherwise. For us, sync actually works better. I don't think we've figured out why it works better, but sync, in terms of app level latency, sync RPC type actually works better for us. And we also did like one major migration. So for example, like we were using commas in our metric names instead of dots, and we tried to change that, and that involved migration work for a month. So if you're trying to make changes, you have to think about your data model really carefully before. And if you have an opportunity to upgrade Cassandra, do it as soon as possible. We postponed it, and we are paying the price now. Yeah, distributed systems are still hard in 2014, so changes are not easy to make. Some of the meta lessons we learned. People typically ask me, why did you guys do this in Java? I don't know Java. So I don't think we can do anything about it. Just patiently listen to them, maybe entice them. And when we open source Blueflood, one of the complaints was like, the packaging is not good. We want to try it soon. So I don't want to be installing Cassandra. I don't want to be doing all this stuff. I don't want to be building a jar. Just give me something that's good to go. So we tried to package it via Docker, and it has worked reasonably. We tried it out with some of our internal customers. They like it, actually. And we should open source early if you decide to do it. For example, Blueflood, I think this 40,000 lines of code is not like exact, but it's around that range. It's not fun when somebody who joins an open source project and sees like 40,000 lines of code. It's daunting. And also documentation. We try to be good at documentation. For example, we have come up with documentation days now where all engineers actually focus and write some documentation. But open sourcing is not easy. Once you do it, it's your responsibility to keep all these things going. So we found like people ask very good questions on email and IRC. So whenever they ask good questions, we try to capture them, convert it into like a document, like a FAQ, where we can refer to people when they ask the same question again. So if you want to like participate, what can you do? So we open sourced this in summer of 2013. It's all Apache 2 license. So if you can hop on IRC, we are upon Blueflood on free nodes. You can start interacting with people. We also have like a Blueflood Discuss Google group for like deep technical discussions if you want to kick off something. I think we're seeing like good traffic every now and then on these things, which is good. Also, questions. Oh my God. So we built this fact section. So if I think like if your question is one of these here, that is good. But if you have like more questions, the onus is on you to actually edit this document and add that question. I'm kidding. OK, questions.
So you said you guys, this is a bit of a, I guess, Cassandra related question, but using S and X, right?
Right.
And so that means you're using Thrift to talk.
Yep.
Have you guys looked at all at the newer SQL
SQL.
stuff they're doing in the native SQL client? Are you thinking about using that?
Yep. So the question is, we use Asterianix. Asterianix under the hood today uses Thrift. So in the newer versions of Cassandra actually have like a SQL interface. Would you have you considered using that? Things like that. Yes, we want to be able to switch to SQL because Thrift support is going to be deprecated pretty soon. I think like Gary's actually looking into it. He's the Cassandra expert. But I don't think we have any findings at this point to like concretely share numbers with you. Yes.
So okay, we are using a metrics service called Libot Metrics.
Okay.
And yeah, a reason why we use it is that application engineers can easily define new metrics in application. Then the log itself describes how that should be summarized or how that should be visualized. Then the question is that how can we create new metrics on this system? I mean, what should we do to create new metrics on this system?
Okay.
New time series, maybe.
Okay. So the question is, it was a long question.
Metadata around the metric?
Yeah.
Sorry, do you mean the metadata around the metric? Is that the question? Or?
So if we don't have to, if we don't have to create new REST requests to create new metrics on this system, it's hard for applications. If we can write just one line to define new metrics, that's very good.
Yeah. So, yeah.
Because adding metrics happens everyday basis.
So the question is, how would you derive new metrics with the system? So there is a clear distinction between events and metrics, at least for us, right? So what you're talking about is events, and metrics could be derived from events. And you can then publish those metrics into Blueflood. But what we are not building is an event data store, right? There are other products that do it well, but we might think about integrating Blueflood with event data stores. But Blueflood's goal is not parsing logs, parsing your events. We want to just focus on getting your metrics and doing the processing really well and with a minimum delay display graphs.
I see.
Yeah.
So if we need to add new event tree, do we need to create a table, kind of table first? Well, it will be automatically created.
So you shouldn't have to worry about creating. So the question is, would you have to create tables when we create new metrics? The answer is no. So all you should do is give us a key, give us a value, and a TTL. And if you want, like TTL and units are optional, basically a key and a value, and we'll figure out where to put it. And all the ugly details of the database is hidden from you.
That's great.
Any other questions? Cool. Awesome. Thank you.